Okay, let's have a look at thermochemistry. If we look at that word, we can break it down into two parts. The first part, the thermo, means something to do with energy or energy change. And the second part, the chemistry, means that the involvement of a chemical reaction. So either the formation of a new product or the change from an existing product. So let's define it. Thermochemistry is the energy changes that accompany chemical reactions. We can take a simple example. We have a solution of hydrochloric acid, and into that solution we put some sodium hydroxide, and we observe that this reaction heats up. So there has been a change of energy in this system. Now, for us to look a little bit more deeply, we need to look at some definitions that will help us in this study of thermochemistry. First of all, we define work as a force that is exerted on an object and the object moves through a certain distance. We use the units for joules, or we use the units joules for, or to measure that work, and we can extend that to the word energy. So energy is the capacity to do work, or it's the amount of energy a substance contains, and therefore is the amount of work that that substance can do. Because it involves work, we also measure energy in joules, and that's important later. Now, for us to have a look at this thermochemistry unit, we need to look at a few other things. And the first thing is that we need to bear in mind conservation of energy. So energy cannot be created or destroyed, but it can be transformed from one form to another. So if we take a plant absorbs light or sunlight through photosynthesis. It transforms the sunlight into chemical energy, which it stores through sugars in its leaves and in its stems. We break down those sugars to allow us to move, so we have kinetic energy. A car uses fuel, and it breaks down that fuel to create movement energy, or kinetic energy once again. So it has chemical energy that it breaks down, or that we utilise to perform mechanical processes which lead to kinetic processes or movement. So in both of these cases, we've actually transformed this energy from one type to another. But we can also transfer energy from one system to another as well. So let's now have a look at that. If I have an object that is hot, and I separate it completely by a barrier from an object that is cold, our two objects will stay relatively hot and cold to each other. On the other hand, if I now allow these two objects to move within the vicinity of each other, we can actually get a transfer of heat from one system to another. So both objects over time will eventually come to what's called a thermal equilibrium. So there's been a transfer of energy, heat energy, between the two systems. The hot one will become cooler and the cool one will be hotter. Now we define this heat or heat transfer as always going from hot to cold. So that's the important thing. We get a transfer always from hot to cold. We never get from a cold object to a hot object. And this is known as a thermal energy transfer. So when we touch a hot object, we get the sensation of heat because the hot object is transferring that thermal energy to us. Likewise, if we touch a cold object, we get a sensation of cold because the heat from our hand, as we touch it, transfers energy to that cold object. And if we left our hand on the cold object for long enough, our hand would cool down. This object that we're touching, which was originally cold, would heat up to the same temperature as our hand. And once again, we call that a thermal equilibrium. Now, heat is a measure of thermal energy. That's the important part about this. Unfortunately, there's often confusion between heat and temperature, and people often say temperature is a measure of heat and is therefore a measure of thermal energy. This isn't the case. If we take an object here, we've got a beaker of water, we place a thermometer in there, and let's say the water is quite hot and the thermometer is quite cold. Once again, we'll see a transfer, we won't actually see it, but there will be a transfer of heat between the hot water to the cold thermometer, and they will reach what's called thermal equilibrium. They'll reach the same temperature. Now, the part about this is that the thermometer doesn't contain as much heat as the water, and we'll go into that more in detail a little bit later. But we can say that temperature is a measure of thermal equilibrium, but it's not a measure of heat. So how do we measure temperature? Well, there are two main scales that we use. First of all, we've got our Celsius scale, and there's two parts to that. 0 degrees C is defined as the temperature at which ice melts. There's a conversion to Fahrenheit as well. And 100 degrees C is the temperature at which water boils. And there's obviously 100 units between these two measurements. So it's a centigrade scale. It's important to note that these two measurements are at 1 atmosphere pressure. Now we have a second scale, which is called the Kelvin scale, which is an absolute temperature scale. And to convert between 0 degrees or degrees C to Kelvin, we always add 273 degrees, or 273.15. So 0 degrees C is 273.15 Kelvin, 100 degrees C is 375.15 Kelvin. If we want to go back the other way, we have to subtract 273.15. So 273.15 minus 273.15 will give us 0 degrees C.